Okay, so now our topic is sedimentary facies. So basically, in this topic, we will mostly be reading about sedimentary deposition environment, right? And this is the most important topic, right? All sedimentology is focus on this only, depositional environment, right? Apart from paleocurrent indicators, all those things, this is very important, right? So to start with, okay, so like just give, I think is the recording started? Okay, so I'll start again. So like this is a topic, right? Sedimentary facies. So in this topic of sedimentary facies, we will mostly be studying about sedimentary depositional environment, right? So like before coming to sedimentary facies, we discussed in the very first class what is sedimentary, like what are the depositional environment. So I think we discussed very briefly about various environment, right? Various deposition environment. So we discussed about this diagram, right? So where all sedimentary deposition happen? Sedimentary deposition happen. Firstly, if like starting with fluvial, uh, starting with fluvial. So firstly, it happens here near alluvial fans, right? This is one of the way, one of the place where deposition happened. Then deposition is also happening along with the river, right? Channel deposits. There is braided channels. There is meandering channel. So you get point bars, all those deposition, right? Another deposition happened here. What is this? This is delta. So you get a lot of deposition in the delta, right? So this is the main area of deposition in the terrestrial domain. Apart from this riverine or fluvial, we also get a lot of time aeolian deposits. The deposits by wind also deposits, right? We also have lake. We call in geology we call it lacustrine deposits. Lacustrine deposit. Then of course we have a lot of deposit in the marine setting. We call it shallow marine, deep marine setting, right? The turbidite, all those things, submarine fans. This is there. So these are the environment. These are sedimentary depositional environment, right? So sedimentary deposition environment, they could be continental, right? Related to river, related to lakes, or related to wind deposits, right? In the transitional setting, we call delta, we call it terrestrial transitional setting, right? So we have delta, the most important estuarines deposits, right? And the marine, we have shallow marine and deep marine. So basically this is what we are going to study in this topic, right? This is the last topic of our sedimentary sedimentary petrology. Rest we have covered, right? So the topic is sedimentary facies. So you should be clear about what is facies, right? So facies means nothing but they are generally just the rock type. These are specific sets of rock type, right? Which were deposited under the sedimentary environment, right? Like what I mean is that if I say you tell me something about delta, tell me something about UPSC will ask you something like that. Tell us something about deltaic sedimentary facies, or tell us something about meandering sedimentary facies. So what this means is that they want to know about this in delta, what kind of rocks, or what are the features or the properties of rocks which are deposited in this deltaic setting, deltaic depositional environment, right? What are the properties, what are the features of the rocks or the sediment deposited in meandering channels, right? This is what it means. You got it? So these are faces are nothing. These are rock types which are deposited under these sedimentary or that specific sedimentary environment, right? So technically speaking, there was a guy known as Shelley, right? There were a lot of guy. So there is this guy. This is commonly mentioned in all the standard book. So he defined 5 parameter of differentiating a facie, right? So So what are those 5 parameters? First thing is, he said geometry, right? So like, I hope you understood, right? This is what is a facies is. I will again explain it here, right? So suppose you go to a place and you are seeing certain sets of rocks, right? This is a set of rock, and again you are seeing certain sets of rocks, right? So this is a first sets of rock, right? First R1. These are second sets of rock. These are third sets of rocks. So they are different, right? Why I'm giving them a different number, because they differ in certain properties, right? They could differ in thickness, right? This could be a deltaic. This could be deposited in maybe alluvial fan. This could be a maybe deep marine, right? So they differ in a lot of parameter. The most common parameter is thickness. Second is fossil content. Third, even more important, is sedimentary structures, right? And what Shelley talk about is thickness, fossil content, sedimentary structures, paleocurrent pattern, right? And lithology, that is rock type, that is the core. So Shelley talks about, right? So one is thickness, fossil content, sedimentary structure, paleocurrent directions, and one is rock type, the most important, right? These could be maybe argillaceous rock, dominant mostly. These could be, maybe arenaceous rock. You understand now what is argillaceous, what is arenaceous? This could be maybe what is rhodaceous? Anyone? ये पढ़ा है ना, ये classification भी, argillaceous, rhodaceous and arenaceous. These are the coarse grain, right? The conglomerates, all those. So coming back here. So now again, like, this is sedimentary facies. So what is sedimentary facies? These are set of characteristics of this facies, means it is set of characteristic of sedimentary rock units which differentiate them from other units and tell us about the depositional environment, right? These are basically sets of the sedimentary rocks, like, which differ in the character and depositional environment with other units, right? That is one thing. So like I said, these are the 5 factors as per Shelley, Shelley, or it is not necessary to use the name, but sedimentary textures, right? Sedimentary structures, fossil, heavy mineral assemblage, right? All those things are important, right? So basically, by studying sedimentary facies, we want to determine the sedimentary deposition environment, right? Suppose we are analyzing a sedimentary facies, right? These sets of rocks, which might be 500 million year old, they might have deposited 500 million year old. So we actually want to know in what kind of deposition environment, what kind of setting were they deposited, right? So basically this chapter is essentially about depositional environment, right? So just to give you an overview, there could be various sedimentary environment. Like just now I mentioned, one is continental, right? I hope this is just rough kind of a thing, but you can make sense of it. So you can make this small diagram in your copy also. Another one is shoreline, or you can rather call it transitional. And third one is marine sedimentary environment. So in continent, what all do we get? We get alluvial fan, alluvial fans we get, right? Deposits which the rock type which we get in alluvial fan, they're also known as fanglomerate, right? Conglomerate type kuch to fanglomerate, right? That is one thing. Then we get river channel deposit. River channels में मिलते हैं. So channels are of two types, right? One is braided channel, another one is meandering channel. All these things we have done in geomorphology, right? If you have not done, you should do it. Otherwise I'll show you some pictures today, right? So these are one. Even in terrestrial setting, there could be lakes, there could be wind setting in wind depositional environment, or you call it aeolian depositional environment, right? In transitional, we call it delta. Delta is the most common transitional environment. And then in marine setting, we have shallow and the deep marine. So this is all we are going to cover in this sedimentary facies chapter. So today in this class, we will cover three. We will cover mostly terrestrial sedimentary environment. So in terrestrial sedimentary environment, what do we have? We will cover these three. We will cover mostly fluvial. So in fluvial, tell me where all do we get? अभी मैंने बताया था where all do we get deposition, where sedimentary deposition happens. Tell me the area, the region, or the name of the landforms. The first one is, suppose this is a river and this is water, right? This is coming to ocean. Now tell me from here where all do we will we get deposition, dominantly deposition. This is the first place, right? The first place is what? Alluvial fan. The second place is,
Channel
yes,
deposit.
channel deposit. So channel deposit are two types. First one is braided, another one is meandering, right? Like I know a lot of you are very new to the course, right? So I will tell you some like I will show you these features or maybe on Google Earth, right? Okay, Google Earth, right? So I have covered all these things in geomorphology, but we can see it here, right? So we'll see some of the settings, right? So okay, this is India. What is this? Can you tell me what is this? Is it visible? Is this Google Earth visible on your screens?
Yes.
Yes, sir.
Okay, so I have zoomed into some part of India. So can you tell me what is this?
Sundarbans Delta.
Yes, this is like for geology purpose. This is Ganga Brahmaputra.
Braided.
Yes, Ganga Brahmaputra Delta. Okay. Okay. Do you know what is this? This one? What is this one? Can you see the cursor? This is also a delta. So which delta is this? Which delta could this be? This is also a delta basically. This is a river coming, and this is Godavari Delta, right? This is Krishna Delta. This one is here. This is Krishna Delta. Are you able to see this? This is Krishna River, Krishna. So that is why we call this area as Krishna Godavari Delta in our general studies. Right? दिख रहा है ना ये? So can you tell me, is there any difference? Is there any difference between this delta? You see the coastline here. You see the coastline here, right? Oh, okay, I'll come back to in the detail of delta after a while. Let us see some more just basic landforms or geomorphic features, right? So let us see some maybe fluvial settings. So basically, this what are these? What is this? This is which river?
Brahmaputra.
This is Brahmaputra. This is Ganga, right? So you can see this. If I'll zoom into this Brahmaputra. How does it look like? This is, we call it a braided river. Braided. You understand what is braid? Braid matlab in Hindi braid means choti, right? The choti generally girls have that choti, right? This is how it looks like. Can you see it? So is tarah, this is also similar like that, right? This is all braiding. So you can see a lots of rivers, a lot of streams are there, and in between there are a lot of deposits are there. So these are all like this, where my cursor is there. This is a vegetated deposit, right? This is a mid channel deposit, we call it. In fact, this could be, what could this be? This could be something like Mazuli Island. Have you heard about Mazuli Island? What is Mazuli Island?
Riverine island in.
Yes, it is the
Oh,
Largest riverine island.
largest riverine island, right? So basically, so this is vegetated also, but simply like this, we have a lot of there. So basically, these are sand deposit here, right? So you can see a lot of sand, lot of water here, and this is Ganga. See, Ganga looks so Fiki before Brahmaputra. Now let me show you something else, right? Okay, maybe we'll see this one. Like, can you see this stream? This is Ganga River system, right? So can you see this one, this stream? So like, what it is? What do we call this one? Which kind of channel is this? This is in Google Images.
Meandering.
Yes, this is a meandering river. Very good, right? This is a meandering river because it is sinusoidal in shape. So we call it meandering river. And here you can see in the inner curve you have deposit. We call them, right? Suppose this is a inner curve. So in the inner curve we get a lot of deposit. In the outer curve we get erosion, right? This is basic we discussed earlier also, because in outer curve the river has to cover larger path, so it travels faster. So if it travels faster, there is higher energy, there is more erosion, and in the inner curve there is deposition. So this is meandering river. So if you will see it, more, you'll observe, if suppose you observe this stream, you will see a lot of other features also, right? Suppose this is something you can see. Can you see this scar? Right, this scar, we call, what do we call it? We call it a meander scar, because earlier the river was flowing in this channel, is tarah ja raha hoga, but now it is meandering, right? So this is a scar basically. There might be more such features. Like, see this here also, right? So this is also a can you see this? Can you observe this feature? Earlier the river was flowing through here itself, right? So now if these meander scars have water, what do we call them? Which landform do we get?
Oxbow Lake.
Oxbow Lake, right? We have studied this. Very good. We have studied this in geomorphology. We have studied this in GS also. GC Leong content. This is also a Oxbow Lake, right? This is also Oxbow Lake. So this is a meander channel. If water is present in meander scar, we call it a Oxbow Lake, right? Ye ho gaya. Now see Brahmaputra. Brahmaputra we have seen, right? Brahmaputra is braided like, uh, right? It looks like braided. So it is an example of braided river. Ganga is largely like, in Ganga also you will get some, at some area you will get braiding all those things. But Ganga, or the Ganga river system, is generally meandering kind of a river system, and this Brahmaputra is very a braiding kind of river system, right? So this is this. Then another like landform I was trying to tell you about, delta, right? Delta we will study maybe tomorrow if time permits. Then today itself. But like I was showing you delta, right? So this is what this is, you said Ganga Brahmaputra delta, right? So before this you observe this Godavari and Krishna Godavari delta. So tell me the features you see here, right? Do you see that these features? There are two things you can see. One thing is that this delta is basically parallel to the coast, right? This is one thing. And another thing is, you can see here evidence of Paleo Delta also. Paleo Delta, right? Can you see this one? You can see like this curve, and parallel to this curve, you can see various curves here also. Can you see this one where I am zooming it? Is it not parallel? Right? So these are basically evidence of earlier delta. Initially, like few millions year old, the delta, this location would have been here itself, but we call this as a prograding delta, right? Here, this is an invert delta, and now with time this delta, or this coastline, has prograded basically towards the ocean, right? Because of all the sediment buildup. So this is one thing which we are seeing. Another thing which we are saying is that the coastline is basically parallel, right? This is the delta, right? This is the coastline, and this is more smooth, right? Parallel to the coastline, right? But what do you see here in Ganga Brahmaputra? So this is one type of delta. Krishna Godavari is a specific kind of delta. There is another type of delta which is this delta, which Ganga Brahmaputra delta. So can you tell me the, like, how are the features? How are the features of this delta? Features of this, whether they are parallel to the coast or perpendicular to the coast. Just let me tell. So these features are, this is the coast, right? This is the coast. So these features are, you can see these are not parallel, these are basically perpendicular to the coast, right? And you can also see this bluish, you can see these are turbidites, right? These are sediments in the submarine setting, right? These are sediments below the ocean, right? And even a lot of research paper they say that this alluvial fan or this turbidite, basically submarine fan, here we will call it submarine fan, this has extended to up to, you know, where, to up to Andaman and Nicobar. You know, where is Andaman and Nicobar? This is Andaman and Nicobar, right? So this is the power of this river, because they are very consistent, they are bringing these sediments from millions of years, like from millions of years. So it has come even to till this place, right? Andaman and Nicobar. So this is one type of delta. There is another type of delta. Let's go back to the, let's go to the other part of the globe. So like suppose okay, do you know what is this? This is also a delta. Which delta is it? Which river delta is this? This is US. This is also a river delta, right? This is a
Mississippi.
yes, very good. This is a Mississippi River, right? So what is the shape of this, right? The channels are like very prominent and very elongated channels, and you can see these channels are even at times they are even continuing inside, right? Here you can see they are even continuing inside the ocean, basically. So it is very much river dominated delta, right? And we call it a bird foot delta. Just give me a minute. So does not this look like a bird, foot of a bird, right? With various, you know, these are the claws, something like that. So this is Mississippi Delta. So this is a river dominated delta. The one which we were talking about, Godavari, Krishna Godavari, that is basically wave dominated delta, right? This is wave dominated delta. Because of this waves, dominance of waves, what do waves do is that this river bring a lot of sediments, right? They bring sediments here, and these waves basically the river, they redistribute the sediment along the coast. Because of that, this you know smoothing of the coast is happening, right? Because of that, this smoothing of the coast is happening, right? We call it protrude, like this is example of protuberance which I shared. This is old coastline, this is newer coastline, so it is protruding into the sea, right? This is one feature. Second feature is this is wave dominated, because here wave is basically redistributing or reworking the sediment, right? This is one thing. Here the third type of delta is Ganga Brahmaputra delta. So this is basically tidal dominated delta, right? So delta is of three types. One is tidal dominated, one is wave dominated, another one is river dominated. So Mississippi is example of river dominated delta. So we will cover delta later. Today we will cover this fluvial, basically deposition, right? Fluvial. So in fluvial, one is braided, one is meandering, right? Another one was alluvial fan, right? So I will show you alluvial fan also before closing this Google Earth, right? So okay, okay, let me search Dehradun, because Dehradun is nothing but it is situated on a alluvial fan, right? This is Dehradun, right? So basically this is all river Ganga, right? This is all river Ganga which is flowing from there here, right? This is the river, and these are shivaliks, and just above shivaliks you have this. What is this? This is Dehradun, the city of Dehradun. So can you see? It is like kind of fan shaped, right? It is kind of fan shaped, basically. So it does not look perfect because it is not a single fan. This Dehradun is it is basically amalgamation of a lot of alluvial fans, right? We call it a coalescence of alluvial fans. So basically, it is that, right? Even like this will be more clear near Leh, right? So like this is Leh, but like I will take this area nearby Leh. Okay, okay, right. So now see this one. This is a river, right? This is a river. This is a river. Which river is this? I think this is Indus, right? This is the Indus River. Can you see the Indus River? This area is pretty close to Leh only, right? So this is River Indus, I think, or maybe some other, maybe Zanskar. But like suppose this is River Indus. So can you see these one? Can you see these? Isn't this a alluvial fan? This is another alluvial fan. This is another alluvial fan. So it दिख रहा है ना? It is fan shaped, right? So you have a lot of alluvial fan, right? It will look better in this way. Okay. So in 3D, it looks even better, right? So can you see now? Is it visible? Can you see these are like group? This is basically mountain valleys. This is mountain valley. So here the sediments are confined in this valley, right? But when it comes at the flat surface, at the plains, it basically scatters, and they are forming fan-like features, right? So can you see these fans? Right, these are a lot of fans. So this is layer area. So this is an example of alluvial fan, and we have covered all this in geomorphology, right? So now any doubt? ये clear है ना? ये तो just basic stuff, right? So okay. So now we will begin with the we will begin with the fluvial setting, right? Fluvial facies. So okay. Any doubt? अभी तक कुछ doubt? Any doubt? Anyone? So the first kind of sedimentary environment is fluvial, right? So firstly, what is fluvial sedimentary environment? This is These are sedimentary environment, or basically this is a terrestrial deposition environment dominated by river, right? This is a terrestrial. So I think I have handwritten notes, so मैं उसी से पढ़ाऊंगा, right? Okay, so this is fluvial. Can you see these notes? Are they legible?
Yes, sir.
Okay, so the first one is fluvial, right? So they are terrestrial. They are terrestrial depositional environment, right? Dominated by river system. So like suppose this is a river system. This is mountain. So mountain के पास like so firstly vis-a-vis a river, geomorphological zones of a river system, right? So a river has three geomorphological zone. The first zone is the zone of erosion. So this is a zone which is present in the mountain region, right? So these are present in the elevated mountain region. River is mostly doing erosion, right? And there that river is doing active down cutting, and here the gradient is high. The gradient is high. The second one is transfer zone. That is a mid zone. Suppose I am drawing the cross section of river. This is mountain. This is mountain, and river is coming like this, right? So the mountains are here. This zone is erosion zone. The middle zone is transfer zone, right? Because this is the zone where mostly transportation of sediment happened. Neither deposition, neither nor erosion. And in the last, like the delta area, mostly deposition happened. So third one is deposition zone, right? So deposition zone mein the gradient is low. In transfer zone, the gradient is like okay, lowish, but river has high energy enough to carry them along with carry the sediment along with them, right? So like just now I mentioned, within fluvial system there are two main environment of deposition. The first one is also floodplain, another one is channel, right? So in channel, basically suppose this is a channel. Suppose this is a channel. suppose this is a channel. So river is flowing in the channel, right? यहाँ पे there are this is embankment, raised part in the river bank. What do we call this raised part as? In geomorphology we have read, we call it levees, right? ये होता है ना, river ऐसे ही होता है ना. This is a river channel, तो ये raised part जो है यहाँ पे embankment of the river, right? We call it levee. So river is flowing in the channel. So basically this channel is, right? So channel basically confines the water flow, right? It confines the water flow, and they may have some embankment which we call as the levees, right? So basically there are two kind of deposition in the channel. One is we call in the braided system we call it mid channel bars, right? And in the meandering system we call them point bars, right? So suppose this is a meandering channel, so यहाँ पे what are mid channel bar, water point bar, these are point bar, right? These are point bars. This is a point bar in the inner curvature, right? And example of mid channel bars are, this is a mid channel bar, right? So this is what, this is that snapshot of Brahmaputra. So basically these, right? Or even this one big one, right? Which we can see green. So basically this is also or sandbar only, right? And इसके आसपास में channel is moving, right? So basically river is moving like this. This is a channel coming, this is again another channel coming, this is again a channel coming, right? Something like this is happening. Then again it is one more channel is coming, and they are joining, then coming. So basically this is all deposition, right? This is all deposition. यहाँ पे जो बीच में, it is all deposition. So this is what we call it an island, right? So इसको हम बोलते हैं mid channel deposits, mid channel deposits, right? All these in between, they could be vegetated. If you have planted, you have done afforestation, this is vegetated, right? So this is Brahmaputra. So what is the difference between this point bar, or basically what is the difference between a meandering channel and a braided channel, right? So example of meandering channel was Ganga, right, in some of its parts, and especially in the later part. And an example of braided system was Brahmaputra, right? So in braided channel, one thing is that the gradient is high, the gradient is higher. Here the gradient is lower, relatively lower. And the second thing is that in braided channel there is tremendous supply of sand, very high supply of sand, right? So you can see in this picture also, like there is tremendous amount of water as well as sand which is brought by this Brahmaputra river, right? That is why this Brahmaputra and Ganga, they have made the largest delta of the world, right? The Sundarban or the Ganga Brahmaputra delta, and that is why they are making an submarine fan which extend up to Andaman and Nicobar basically, right? So because they have tremendous, so Brahmaputra and large and right, steep gradient. And then this is meandering channel, this is Ganga. So we have discussed all these points, right? These are meander scar, and if they have water we call them oxbow lake, right? This is a meandering channel basically, and this channel keeps on shifting. Like I said that earlier, the channel might be flowing इस तरह कुछ flow कर रही होगी, right? इस तरह, this in this way it might be flowing, but now it has shifted to this, right? With time, it might flow like this. इसके बाद हो सकता है it might flow like this, right? Something like that. So this is also there. The shifting of channel is very common, right? We call this shifting of channel, the deposition because of shifting of channel, as lateral accretion. Lateral is, that is laterally, accretion is इकट्ठा हो रहा है, right? So basically this is deposition, lateral accretion, because of this shifting of channel. And again, if this is bar deposit, the outer bank is known as the cut bank, right? Or where erosion happens. So this is also common thing, right? So like just now I mentioned, the two main types of river channel is braided channel and meandering channel, right? So now firstly we will start with braided channel, braided river, and we will see what kind of deposition environment is there, what kind of facies do we get, and here we will cover the facies, right? Facies wala part. Okay. So okay, so the first one is braided river, right? So what a braided river? Brahmaputra is prime example of a braided river. So these rivers are those rivers which have high sediment load. This is important keyword. They have high sediment load and they have steeper gradient than meandering river, right? So if you will read books, if somebody, you don't have to read book, but if somebody read book, then this braided channel are also known as बेड लोड रिवर, राइट? अब सपोज यूपीएससी ने आपसे पूछ लिया डिफरेंस बिटवीन बेड लोड एंड मिक्स लोड रिवर चैनल, right? If UPSC asks you difference between bed load river channel and mixed load river channel, so you should know that the braided river channel, they are known as bed load rivers also, right? So why do we call them bed load? Because we have read about mechanism of transportation, right? TSSS. So one is by this traction and saltation, another one is by suspension, right? So if river river has low energy, if river has relatively low energy, it will carry in what form? Whether in a bed load form or whether in suspension form. Which form will it carry? If a river has low energy, it will carry sediment in suspension form or in through bed load form, through saltation or all those. Tell me. Anyone? Are you still there or you have lost? Okay, so Navdeep or जो भी यहाँ पे, if a river has low energy, so what are the chances? Will it carry the sediment in suspension form or through bed load?
Bed load.
No, if it has low energy, that means that there is a chance that
Lower.
it is carrying finer sediments, right? Finer sediments are mostly carried by suspension, right? So braided river has high energy because we are talking that they have steeper gradient. If they have steeper gradient, that means they have higher energy. So that is why we call them bed load. They carry a lot of sediment through the bed, right? Along with their bed, right? Through traction and through saltation. So that is why they are named such way, right? You should remember this. So these sediments are deposited. Clear ना? इस बात पे clear हो गया ना? Is it clear?
Yes, sir.
Okay. So the sediments are deposited in mid-channel bars, right? That is one thing.
Yes, sir.
Okay. Okay. Thank you. Thank you. Right. So basically, the sediments are deposited in mid-channel bar, which divide the flow, right? Which divide the flow. So this is I made a 2D diagram. This is a 3D diagram, right? This is a 3D diagram. So basically, these are river channels. This is river is flowing here, right? These are various channels, and this is what, this is mid channel bar. These are deposition. Here deposition is happening, right? This is one thing. And so like this is what you should know, right? Another thing is that sometimes like here this sign is for mud, for mud. So basically this is a river channel, right? ये जो आपको narrow depression दिख रहा है ना, this is the confinement of a channel, right? Beyond the channel, suppose when will the water will go beyond the channel? You observe this in Assam a lot of time, right? Assam has a lot of flooding. So why does flooding happen? Because the water overshoots the river channel, and this deposition which we are seeing here as well as here, these are nothing but these are, we call them overbank deposit. When the river flow over the bank, right, over the bank, uh, when the water flow over the bank of river, they deposit, right? So basically these, you can say that these are flood deposits. When the flood came, or you can say these are the floodplain deposits at the floodplain. So what kind of deposit will a floodplain have? whether what kind of energy setting does a flood have? Flood plain. When flood come, what is the energy of the river or energy of the water? Right? You must have observed that when flood came, the water is stagnant. The water is mostly stagnant, so you will get mud deposits. Right? You will get mud deposit, fine deposit, because the flood water is mostly stagnant. The energy is in the river, right? River is flowing at very fast speed, that is within the channel. There is high energy condition, but if it overshoot the levees, right, if it overshoot the levees and it flood the nearby area, here it is high energy because the river is flowing. But if the river flow over this, and in these areas, right, this is flood plain, right, flood deposit, or you can say that overbank deposit. So these are low energy deposit, that is mud deposit, mud silt deposit. So coming back to this diagram, like I hope you understood. Now this is very simplistic. Like this is 3D diagram. This 2D diagram is this, right? Simple. You can draw. This is a river channel, Brahmaputra, and you get a lot of these are bar deposits, right? And this is mostly sand. This, like it could be coarse, right? And here, if you get, just give me a minute. Okay, here, if you are getting any deposit here, these are flood banks. These are right. Here you will get mud deposit basically. Here in this setting we are calling it as overbank deposit, right? What else do you see in this figure? Like this is a perfect, you can make it is all right, otherwise you can make 2D diagram also, right? So here I want to show you this. What are these, right? These diagrams, these diagrams, this is in this diagram we are trying to show sedimentary structures, right? So these are trough cross bed, these are cross beds only, these are cross beds only, trough cross beds. What are trough cross beds? We have read now, if the bounding surface is curvilinear, right, these are cross bedding. If the bounding surface is planar, that is planar cross beds. If the bounding surface is curvilinear, we call them trough cross beds, right? This is the term. So we are trying to show the trough cross beds also, right? So this is one of the thing. Now this is important, right? And this is what, if this is asking you something on facies of meandering river channel, if you are able to write this much now, if you are able to write this much, इसने में ही you will get 90% marks, right? Firstly, a lot of people are afraid of this topic facies, because when you read book, all this thing you will not get much in this bangad and all this thing, right, in proper way. And if you read good books, it will take you to volumes. You will have to read a lot of content, so people find it bit difficult to comprehend and all those things. So most people leave all this topic, right? But they're very very easy. You understand them once, make quality notes, and you are done for life, right? You won't even need to revise them much, right? So this is what I'll write. So like I'll explain it differently, right? So what is this is the important about what we are doing. We are reading about braiding river system, right? Braided river system. So what is the what kind of rock do we get? All right, what are the facies, or rather say the character of facies features, right? So इसमें क्या क्या लिखना है आपको? Firstly, you should write these. First point is about lithology, right? In facies, what all dimension do we cover? Like I said initially, we cover about lithology, right? Lithology लिख दो. Sedimentary structures के बारे में if you can write. What else should we write? We should write about basically geometry, right? The thickness of beds. And the most important is we should try to draw a sediment. We call it a sedimentary log. We have seen this earlier also. This is the USP of this topic, sedimentary logs. I don't know why my pen is, okay. Just give me a minute. Can you see? Okay, it was lost somewhere. So these are the dimension you should write. So in the facies character, the first point you will write is, firstly, in case of braided system, what will be the sediment size? Tell me what will be the sediment size. Here energy is higher, right? Energy, like I said it here in Brahmaputra, you can see energy is high. There is lot of water, lot of sediments, right? So here you will not get much, no mud deposits in the channel, right? So here in the channel, this is Brahmaputra river. Here you won't get much sand because here the gradient is high. Gradient is high, energy is high. Here you will not get much mud deposit. Here you can get mud deposit, but these are floodplain, right? So this is a 1.1 observation you should write, right? The second thing is, in the channel, so if you don't get mud, what will you get? You will get sand, right? Sand deposits in the channel, but these are very extensive. These are extensive sheet like, extensive sheet like sand deposits. I will show you some field images also, right? And the third thing, third character is maybe about sedimentary structure. So what sedimentary, because this is high energy condition. And high energy, what kind of crossbed do we get? We get trough crossbed. Trough crossbeds are present, right? Just these three character if you can write. I have taken nothing, but I have taken these from nowhere, but from this 3D diagram only, right? So there is no mud. There is like this dot 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 dot. These are all mid channel bars, and these are sand deposit, right? We don't get any sand. We get a lot of sand. We don't get any mud, and right, we get a lot of cross beds, trough cross beds. That is one thing, right? Now this is the core of sedimentary facies. If are able to learn this, what this means, you will be 10 mark ahead, right? If it is a 20 marker, the examiner will give you 18 mark, right? इतना impactful है. So this is nothing, we call it sedimentary log. Sedimentary log, on desi bhasha you can say it is a facies diagram, right? It is a facie diagram. So what like I'll help you draw what you can add here, right? So this is the character, and the last thing is you can draw a diagram. So basically this is facies succession, right? You are trying to study facies ka succession, right? What succession of deposits do you get? A facies succession of deposit through we call it a sedimentary log, right? So इसको ऐसे draw करना है आपको, right? What you have to draw, this is nothing, and this we will draw in almost all depositional environment. So this is basically this is grain size. I hope you are following. Please focus here, this is important. वरोध समझ में आ रहा है ना? Okay, so this is how you need to draw it, right? So basically इस तरह कुछ है. What you are drawing, this is grain size, right? if I am drawing, अभी मैं ऐसे रफली बना रहा हूँ, if I am drawing इस तरह का कुछ बता रहा हूँ, ये this is a deposition you are getting and this is a deposition you are getting. आप what will you interpret between them? Tell me about the grain size. Tell me about the grain size. This is A, B, C, D. सबसे ज्यादा grain size किस layer में मिल रही है आपको? In which succession are you getting? Most coarse grain?
C.
Yes, C is greater than the सबसे ज्यादा C है, then you are getting B, then you are getting D, and A इसका मतलब just ये हुआ कि A में the grain size is very low. So there is a chance that this is mud. There is a chance that this is conglomerate, and this is maybe sandstone. This is also a sandstone, right? This is what it means. Nothing more than that, right? If you are getting a sequence like this, इस तरह कुछ मिल रहा है, what will you call this one? This is fining upward. Do you understand what is fining upward? If it is like this, here what this means fining upward is the grain size is getting fined as we go up, right? As the sequence we go the changes, right? If it is like this,
Sir, is this the cross section of the layer from bottom to top?
yeah, yes, it is something like that, right? You are plotting, suppose this is a river channel, this is a river channel, right? Braiding and all, suppose you have picked a point A, and now you are seeing, right? If you at this point A, what kind of succession will you get in a meandering channel, or in a braided channel, or even in a deltaic channel, right? Something like that. So just समझ में आ जाएगा अभी, what you said is right? So this is finding upward, but ये important है, ये समझ में आता है ना इतना कि this is the thickness. So in case of, suppose you are drawing for what? Braided channel. सिर्फ इतना सा बनाना है आपको, braided channel. So braided channel का फिर से I will show you the diagram. Just see this one. Okay. So you will get, सबसे पहले हमेशा we have to draw the channel, right? A point in the channel. So point in the channel को इस तरह draw करेंगे, right? This is, and in the channel, what you are getting? You are getting this mid channel deposits, right? This is very high energy condition, kind of. So these mid channel deposits are of which size? They are mostly sand, right? Coarse sand kind of deposit. So suppose this is like this, right? उसके बाद, but this is channel deposit, right? उसके बाद deposition in the channel, and then you are getting the bar deposits. So this is also coarse grain, only slightly finer than the channel deposit. So इसको मैं यहाँ लिख देता हूँ, this is channel deposits. Channel has the highest energy, right? Then we have the bar deposits. They are also pretty fine grain. और कुछ मिल ही नहीं रहा इसमें अपन को, और कुछ चैनल के अंदर हमको मिल ही नहीं रहा, right? This is what we are getting. We might be getting some deposit in the channel, and then we are getting mid channel deposit, right? So there will be repetition of this pattern basically, right? फिर से अगला पैटर्न ऐसा कुछ होगा, something like this, right? So this is mostly all sand and more or less same ही है, right? One thing we should always draw, right? This is all channel, right? This is basically base of the channel, right? And base of the channel, that is one thing. So here water is flowing, energy is high, so the basically we have coarse deposits. This is basically bar, point bar deposit, right? They are also pretty coarse grain only, thoda bahut slightly finer hoga, but not no mud, right? You won't get mud here. Then again you will get this channel bar. This is repetitive, right? So isko kabhi kabhi we call it multi story sand succession also, in like in book Pettison. If you'll read Sandbox all, you'll find they have written it multi story sand succession. This is grain size and this is thickness, right? Basically, right? This is like one thing. So and apart from this, like let me tell you now, ये तो मैंने समझाने के लिए बताया ना. Let us see the real diagram. So this is the real diagram. This is what if you have to draw. अब इसमें complication क्या आ गए? In this diagram itself, इसके साथ में you can always draw an overbank deposit because these rivers keeps on shifting, right? These rivers keeps on shifting. So अभी ये जहाँ पे river है, earlier this might be a, suppose this might be a flood plain earlier, right? So this channel has come. So नीचे हमेशा you can draw a overbank deposit. You can draw overbank deposit. So overbank deposit matlab here it is what? Flood plain itself, right? Flood plain deposit. And what kind of deposit does flood plain have? They have finer, right? They have mud basically. तो इसको ऐसे आप दिखा सकते हो. तो right, this is one thing. Now second thing is in this diagram itself you can show sedimentary structures also, right? I will like इनको मिटा के I will make sedimentary structures, right? So what kind of sedimentary structures you will get? Like we saw, we are getting a lot of trough crossbeds, right? Trough crossbeds we are getting. So you can draw such something like this, right? Trough crossbeds. Here also you will get mostly trough crossbeds, but now energy is decreasing. Here you might get some linear crossbeds also, right? So like just focus on this diagram and you can copy this, right? So firstly, ignore what is made inside them. Just focus on the outer, right? This is overbank deposit. You understand why we have overbank deposit, right? This could be mud deposit, इसलिए इतना छोटा है, right? And here I have drawn mud only, right? And here then we have channel and bar deposit. They are mostly of coarse grain size. Then again channel bar, this thing repeats, right? Here this dot shows erosional feature, right? Erosional bank. Above that, this simple diagram इस तरह जो बनाया है, this is showing trough cross bedding, right? Trough cross bedding. थोड़ा ऊपर आओगे energy will decrease, right? So they are getting planar cross bedding and उसके ऊपर you will get lamination, right? Cross lamination. So how you will draw this ripple marks or cross lamination in this manner, na? This is the diagram. This is the symbol to show them, right? Something like this. So this is what cross lamina or cross beds. This is planar cross bed. You can draw ऐसे भी draw कर सकते हैं. And these are trough cross bed. You can even draw it that way, right? So these are symbol. Basically you can draw this symbolically in this. So ये हो गया in bar. Same thing is repeating. Trough cross bed, planar cross bed, and this cross laminae, right? Again trough, planar lamination, and then you are getting ripple mark or something, right? So इतना ही draw करना है. तो अगर आप ये ना भी बनाओगे, even then it is fine. But if you are able to make sedimentary structures also in these, you will get full marks, right? I said 18 out of 20 kind of thing, right? And ये इतना difficult होता नहीं है. It is not perfect. ये सब कुछ मतलब approximate ही बनते हैं, right? So you can see. So this is an ideal diagram. Even if you read book, उसमें भी इसी तरह के diagrams बने होते हैं, right? So this is what you should master. You should make in your notes, right? मैं इसका आपको और भी simplified भी दूंगा. For example, I have my okay. So like this is kind of deposit, right? So you are mostly getting simple एक ही deposit है, बीच में you are getting some sand, right? तो इसको बाद में we will discuss. अभी इसी पे focus करते हैं. Okay. So this is the first, that is Braided River. The second is Meandering. So Meandering is also called as mixed load river, right? So आपको मैंने explain कर चुका हूँ. Why do we call it mixed load river? You tell me. Why? What could be the reason we call it mixed load river? Because here in meandering, the sediment is mixed basically, right? You will get bed load sediments as well as suspension sediments also, or you call it suspension load also. So here we call it mixed load because you get bed load as well as suspension load sediment, right? So ये तो छोटी सी बात है, but important is this meandering. So this is now meandering channel. So firstly, where are these meandering channel formed? These channels are formed in regions of low gradient. So we observe Ganga. So in river Ganga, it was getting a lot of meanders in the later stages, right? When it has come near after even Kanpur and all, it becomes a lot of meandering. When it enters Brahmaputra, sorry, when it enters Bengal, right? It flows in this sinusoidal way. So these rivers have sinusoidal character, right? That is what it means. Meandering means, right? These deposits are a mixture of sediment load and bed load. That is why these deposits are also known as mixed load, right? The same repetitive thing. Then meander develop. So how does this meander develop? They develop by erosion of bank closest to thalweg and deposition on the other side, right? So basically, this is me. Suppose this is a river. So what is thalweg? What is thalweg? Thalweg is nothing. It means center of channel. At the bottom, right? This is river. So the center is at the bottom. This is thalweg of the river, right? Center of the river. So basically, this is saying that the erosion happens on the outer surface and deposition happens on the inner surface. Simple. This is what it is saying. And this is the most important word. If you are able to write this, if suppose UPSC is asking you something faces of meandering river system, if you are able to write this line and you are not writing anything, now you will get 2 marks directly for this. Like this is the core of sedimentary facies. So here the profile of succession is finding upward and lateral accretion, right? So you understand what is a lateral accretion, right? Lateral accretion means, like I will explain it here. Like how does a meandering river flows? Something like this, right? This is a meandering river. This is a meandering river. Sorry. Right? This is a meandering river. But what will happen with time? This is mildly meandering river, right? Now what will happen with time? It will become more like it will meander more, right? It will become more sinusoidal. Something like this, right? Something like this will happen. So what is happening is, suppose you focus on the here deposition is happening, right? In the smaller curve, right? Here deposition is happening. You understood now? Here deposition happened. But now with time what happened? More deposition will happen here, and this is the new river. The black dotted one is the new meandering river. With time, the meandering is increasing basically. So suppose this is point A here. Right? So what is happening here? There is this lateral. There is more accretion of the sediment laterally. So this is lateral accretion. Right? So at A, you will what will you find at A? You will find a channel and then a point bar, right? Firstly, what will you find at A? I think somebody is there. So at A, you will find a channel first, and then you will get a lot of point bar and other deposition, basically. So like again, explaining it simplistically, you can, this is a channel. Suppose this is a channel, right? So what is happening? How is what is lateral accretion? Is this right? So this is what which is happening. More and more deposition is happening, right? So this is what we call it lateral accretion. Basically, the sediments are building up in this direction. So like again, coming back to the main notes. So another thing is that, so we will again see how we have to plot this in the diagram. Now another point is this meandering river system is basically they have more mud than braided system, right? We also saw this in the case of Brahmaputra and Ganga, but because braided river system has more gradient, they have more energy, so they carry coarser sediment, right? Here they have more mud than braided river system. That is one thing, right? So that is why I think in braided system, when we draw the log, I gave it the name what multi-story sand, right? We named it multi-story sand. Multi-story sand, ये भी sand है, इसके ऊपर भी sand ही है mostly. This is also sand, so we are calling this is multi-story sand. But when you will see यहाँ पे, you will get mud also, right? You will get mud size sediments also in meandering river system, right? That is one thing. Then it also has lag deposits. What are lag deposits? These are coarse grained, basically coarse grained deposits, and they are deposited at the base of the channel. They are deposited, or they are formed due to removal of fine grained sediment, right? At the base of the channel, present at the base of the channel, right? Suppose this is the channel. इसके base में, because of erosion of fine grained sediment, only the coarse grained sediment is left. We give this term lag deposit, that is there. And this is the keyword, right? This meandering river system will have overall finding up succession, right? Sometime UPSC can ask you directly, right? Write a short note on a one sedimentary facies which have a finding up succession. So you can write about meandering river, right? That is one thing. So this is how you will draw the log. So before drawing the log, you can again see it here, right? This is a river channel. This is a river channel, right? At the inner part, at the inner curvature, you are getting sand deposits. We called it point bar, right? We call it point bar. And river channel के banks के ऊपर there is a elevated portion, what we call that elevated embankment along a of a river bank. We call it
Levies.
levees, right? Very good. We call it levees. These are basically natural dam of a river bank, right? कभी कभी होता है ना, लेवीज टूट गए, ऐसे कुछ जगह सुनने में आता है ब्रह्मपुत्र में कि लेवीज हैव ब्रोकन, राइट? दैट एम्बैंकमेंट हैज बीन destroyed, and then flood comes drastically, right? But before breaking, these levees can, they can naturally develop some minor cracks, right? Suppose this is a river. Here river is flowing in the depression, and these are elevated portion, but these portion might sometime develop some cracks, right? Some cracks, we call those cracks as crevasses, right? This is another term for cracks, that is crevasses, right? Crevasses, you must have heard of this term in glacier setting, right? A lot of time mountaineers, they say that they were fallen into the crevasse, and then they were injured, maybe some of them even died, something like that. So because of this, sometimes what will happen, if there are some cracks, this water can flow out of them, right? And that water will also bring certain sediment, right? So basically this is like flood, right? This is like flood kind of a thing. So here these deposits we call them crevasse splay. This is important. Crevasse splay. SPLAY, right? That is another kind of deposit. Then again, in this meandering setting, you can get Oxbow Lake. Oxbow Lake will be much like point bar only, right? Nothing difficult. And then near them, we could also have this floodplains. So this floodplains will have what kind of sediment size?
Mud.
Mud. Yes,
Mud.
yes. So this black sign is of mud, right? Then we are getting lateral accretion. You understand what is lateral accretion also, right? And these are cut banks. Cut banks are the bigger curvature, right? So you understand all the keywords, right? The important one is this crevasse splay. Up, see, and what kind of sediments sediment size can you think might be there in crevasse splay? Fine grain or coarse grain or random kind of thing, because they are cracks and water will come out of them along with sediment all of a sudden, like in great velocity. So basically they will have basically coarse grain only, or mixture of all kind of, and then they will deposit, right? So this crevasse flake will also be there. So these are the important terminologies associated with a meandering system. Now let us plot this on the sedimentary log, right? So I will draw it here, and then I will show you this diagram, right? So इसमें देखो what you can draw here is this. And one thing is, it is generally finding upward, right? This is a keyword there. It is finding upward, and lateral accretion is there. So you can just draw it like this here. You tell me. This is grain size. We are drawing sedimentary facies succession of meandering river system, right? So सबसे पहले we will get what? We will get a channel का base of the channel, right? Obviously, since these are shifting, these are all shifting. So उसमें बाद में आऊँगा. This is always draw base of the channel as some erosional base, and erosional base are never very smooth, right? तो ऐसे कुछ draw कर दो. This is the base of the channel base, or you will call it erosional base, right? Channel has relatively higher energy, so they are, ठीक है, ये ऐसा है. उसके बाद उसके ऊपर what we will get, you will get, these are mostly like coarse grain. Above them you will get point bar, right? Firstly you have channel. What else you have? Point bar also there. और पॉइंट बार के अलावा व्हाट इज यू आर गेटिंग फ्लड प्लेन, राइट? दिस इज व्हाट यू आर गेटिंग इस डायग्राम में. दिस इज व्हाट यू आर गेटिंग चैनल, यू आर गेटिंग पॉइंट बार, एंड देन यहाँ पे फ्लड प्लेन है. दिस इज ऑल फ्लड प्लेन बेसिकली. Like who is coming to the class? Ashutosh. Ashutosh, is he here? Ashutosh? Okay. Because you should not be asking permission to enter the class, because सबका मेल आईडी ऐड किया हुआ है, right? So like what I was telling is, this is like it get distractive, right? Okay, so I was saying कि हाँ ये channel है, flood plain है, and हाँ, so here you get flood plain. This all is flood plain, which I was trying to. This is all flood plain, right? This is all flood plain. In flood plain, sometimes you might get crevasse splay also, right? This is crevasse splay. This is crevasse splay, right? This is Oxbow Lake. Sorry, this is here. We are getting crevasse splay, right? Coming from here. So this is what we need to draw in our diagram. So what you will get? You will get erosional base. You are getting channel, and then you are getting point bar. Point bar channel is very coarse. Channel is very coarse grain, right? This is channel. This is channel. Channel is most coarse grain. Channel के अलावा you are getting point bar. So point bar is also decently high energy, right? So this is also mostly coarse grain only, right? And then after that you are getting floodplains. So how are floodplains? Floodplains are even small size, right? This is mud. This is sand. This is coarse sand, basically. And in this mud plain itself, you might get beach में crevasse. These are crevasse splay, right? And these are coarser, right? कभी कभी these are coarser. तो ये चार चीजें दिख रही हैं इसके पूरे में, बस यही शो करना है. इसको आप थोड़ा स्मूथली बना सकते हो, राइट? यू डोंट हैव टू ड्रॉ द ब्लॉक. तो इसको इफ यू वांट टू ड्रॉ इट इन मोर स्मूथली, you can draw it like this, right? You can draw it something like this. So uh, whether I should, this is still not right. इस तरह दिखा सकते हो. बेसिकली इट इज फाइनिंग अपवर्ड, बेसिकली, राइट? यहाँ पे थोड़ा और इट शुड बी, इसको थोड़ा और कम होना चाहिए, बिकॉज यू आर गेटिंग right, something like this. So this is the sequence. So this is what, this is channel, this is point bar, this is floodplain, and here you are getting some crevasse play also, right? That is one thing. And then again iske niche again you would get floodplain. So again draw smaller one. Mud is here, right? So let me show you the real diagram. That is one thing. Iske आसपास में, इसके साथ में, if you don't want to make it very hodgepodge, so what you can do is इसके साथ में यहाँ पे इसको बनाने के बाद here you can draw, the relevant sedimentary structures, right? Like now see this diagram. Like see this diagram. So here you are getting basically channel. This is erosional base, right? So you are drawing it little bit rough, right? And then you are mostly getting channel, then point bar, and then floodplain. So you understand why I am drawing this one. See, ठीक है? अब now इसके अंदर जो बना है, whatever is there inside it, it is all showing sedimentary structures. So channel, this is what lag deposit. I said at the base of the channel you get lag deposit. Lag deposit is basically gravel size or coarse grain, right? This is what its definition is. Then उसके ऊपर you will get coarse to medium sand, right? With, and this is the sediment. And what kind of sedimentary structure? You will get large trough cross bed because energy is high, right? As you move up, you will start getting small trough cross bed or simple, right, rippled structures also, right? Planar cross beds you will start getting, and even the sand size will become finer, right? But still point bar have sand size only, right? That is one thing. And then you will get floodplain. Floodplain is nothing but it is mostly clay or mostly mud. You should better write it mud, right? And what kind of sedimentary structure? You don't root drift chhod do, you get generally mud cracks, right? It is common there. And you can also get sand in between. You will get sand size crevasse plays also, right? This is important. And you will get planar cross beds. So this is what it means, right? I hope it is very very like self explanatory. So this is what you need to draw. Aapko is sedimentary log, the one thing which you need to draw is this. This should be something which is rough. And then whatever kind of succession you are getting, this is finding upward. So you can draw this one, and you are drawing thoda thoda beech mein bade. These are basically crevasse splay, right? And this is there. Then the second thing you can draw is sedimentary structures. But sedimentary structures में परेशान होके ऐसा नहीं करना कि you are not even drawing the, sedimentary logs, right? Like I have this diagrams with me. In these, sedimentary structures are not made, right? Like I will show you some of the logs. Like this is a log, right? This is a log of Meandering River. We have covered this one, right? And like I forgot to mention that if you UPSC is not, don't ask much on facies, right? Much on sedimentary facies. But in I think 2018 and again in 2020, it has asked on this topic in either in civil or in forest. So that is why it has gained again importance. right? But otherwise it was not asking. It was mostly asking on sedimentary structures. But in sedimentary facies, if the question will come, 80% of time the question will be on fluvial only, right? And even in fluvial, the most important is meandering, right? So if there are, if UPSC asks question 5 time on facies, 2 time it will be on meandering system, and 2 time it will be on delta system, and remaining 1 time it might be on braided system, or marine setting, or alluvial fan, or lake, or what else, aeolian, all those settings. So these two are most important, meandering as well as delta, right? I hope you understood what I just say. So this is a diagram, right? This is a diagram of meandering. So इसमें I don't wanted to, I was doing it by myself, I was reading the book, so I don't wanted to complicate it with sedimentary structures. So I thought कि भाई नहीं लिखूंगा मैं, I will just write this much. So this is silt clay, this is sand, meandering का बता रहा हूँ मैं, this is erosional base, and this is channel deposit. Channel deposit we know is coarse size, gravelly or coarse sand, right? Then we have point bar, which is sandy, and then it is repeating, right? So this was this multi-story sand, right? Here gravel ki jagah you should write coarse sand, right? So this was the meandering deposit, right? Similarly, if braided system का कहीं बनाया है, या maybe I have made the diagram of mm, like I'll show you, right? Different types of diagram. इसके पहले भी बना होगा. So you can also skip if you find sedimentary structures a bit complicated, you can skip, right? Like this is also there, but I'll show you these. I'll show you this later. So right, but this diagram is very informative. You should not be intimidated by it. Isko make it in your copy. Like you can have it. I'll upload this after the class. But you make it firstly skip kar do sedimentary structures. But you can see sedimentary structures are also varying very logically, right? Whenever there is high energy, you are getting trough crossbed, then planar crossbed, then you are getting cross lavender, right? Or simple crossbeds kind of a thing, ripple marks, all those things, right? You are getting. So it is pretty easy. This is the diagram. This we have completed, right? Uh, so like this, these are the images, right? Field images. So I think this one is nothing but this is a braided system. This is a field image of braided system. So you can see in braided system, I said that you get sheet like sand deposit, right? Sheet like sand deposit. So these are why sheet like sand deposits, right? Similarly, this is again the same picture, but just zoom in. So here you are getting lot of a lot of trough crossbeds, right? This is also there, this is also there. So you are getting a lot of trough cross beddings here, right? So this you can see here, right? So this is something which you can find. Oh, it doesn't go on. Okay, so like again, so this is also again a photo. This is again a fluvial system. This is again a fluvial setting. So like array, like this is again a fluvial setting, right? Why it is like so evident it is fluvial, because you can see this reddish color, right? Here it is reddish. So if it is a terrestrial deposition, it generally have reddish color because of oxidation, right? The marine uh, facies generally are black, right? They are generally very dark, right? So this is one of the like example you can see, right? And I think there was one more good picture. I think this is a very good picture. So this is basically channel deposit, right? You can see this one in field. This is basically, you can see this. This is just a sediment. This is just a there is not much accretion, but this is a channel deposit, right? So you can see this is nothing but this is sand. This looks pretty hard, and this is basically mud, right? This is like softer, unconsolidated kind of feel you can have here, right? So like you can see we are reading things which we have read in geography, right? But geography deal very superficially. It deals with the modern environment, right? If you, this is river, this is meandering, this is braiding, simple. This is alluvial fan, this is waterfall. But in geology, we also go to past, right? Here we are trying to predict what it is, what could this be in the past, what processes were happening. So geology is also about history, history of the processes, right? What happened, all those things. So like this I have covered. Okay. So again, I think we could only cover two, meandering and braiding, and I took a lot of time. But now we will cover it, right? This is the process. We have to explain the landform, uske thode se geological features, right? So a lot of people keep asking me, sir, if you have to write on meandering system or on braiding system, geology, geography people also know all those things, right? But I don't think anybody with GS knowledge can write all those things, right? They can draw this diagram, they can talk about the gradient. They don't talk about gradient, right? They don't talk about finding up sequence and these kinds of diagrams. So this is what differentiate your answer from geomorphology or a geography kind of answer. So that is like one thing. So we covered meandering and we covered braiding system. Now we will cover alluvial, and after alluvial our terrestrial setting will mostly be over, and then we will cover deltaic, and then in one lecture we will complete with marine deposition, right? So I will give you short notes for all those, right? This is very easy. I think we can cover it today also, but I think we will stop. It is already 8:30 and this was kind of extra class, right? So any doubt, anyone till now?